the law of cosines, we have it written two ways. It's the same formula, it's just solved for different variables. It all depends on what you're given, which format of the equation that you will want to use. This first one right here is if you are given a side or two sides really, and the included angle between them. So you'll recognize side angle side from our congruence back in chapter 4, the two sides and then the angle between them. If you're given these things, then you can use the formula in this format, and I've rewritten it 2 times, and all that is writing it to show you that if you're finding A, then you would set it up like this one where you have the cosine A on the end, and if you're finding C, on the end is cosine C, and sort of the letters will be rearranging themselves. And once you practice this formula, you will get comfortable about it, because it's not even going to be A, B's, and C's when you're doing the formula. It could be some crazy triangle with like X, Y, and Z or whatever, and it won't matter. It's just the one that you're finding is alone, and it's squared. And then the other two are squared and added. And then you will always subtract 2 times the two sides you have times the cosine of the angle that's across from the side that you're missing. And I know that right now it's sounding complex, but once you practice it a few times, it will make more sense. And I am going to give you that formula. You don't have to memorize it. Okay. And then if you're given the 3 sides, this is the formula that you'll want to use. It looks much simpler, but really all it is you had solved for the cosine of the angle part in the previous formula so that you could get that alone. So let's use the law of cosines. It's asking us to find the length of C. In this particular problem, we've got 2 sides and the angle in between. So we're going to use the first version. They were nice and they used A, B, and C. Since we're finding C, we're going to be using the one that I had rewritten for C up here. So you get the hang of it, we'll just be going with that written formula there. So C squared equals A squared. Remember, A is across from angle A, so A is 10. So 10 squared plus B is across from angle B, so B is 14. So 14 squared minus 2 times A is 10 times B is 14 times cosine of angle C, which is 60. So we filled it in. Now we just need to simplify it down. I don't like to do too much at one time. I'm going to simplify this part right here. 10 squared and 14 squared is 296 minus 2 times 10 times 14 times cosine 60. Might as well put that in there all at the same time. So we are subtracting 140. I want you to not be worried if this ends up being a negative number. When you minus a minus, you'll be adding, okay? And it does happen sometimes, and the first time it happens, it always throws people off. 296 minus 140 is 156. So let me bring my C squared down. And then we would square root. So you could either go radical form or decimal form. I'll be okay with decimals on this. Decimals would be 12.49. If you did do radical form, if you divide by 2, you get 78. If you divide that by 2, that would be 39. 39 is 3 and 13, so that's not a pair. We've got a pair of 2's. Lonely 3, lonely 13, so the radical form would be 2 root 39. Depending on what your worksheet asks you to do, it'll probably tell you how many decimal places to round to, but if it wanted an exact answer, you would need that radical form. So that's C, and that's all that we were having to find on that problem using the law of cosines. So in this problem, we had to draw our own picture. I made B look obtuse. I made C be the longer side. I made A be the shorter side and connected. And then we labeled our triangle. So now we need to solve it. So we need to find everything that's missing about it. So first, I realized that the only angle I have and the side opposite it, since I do not know both of those things, I cannot use the law of sines to find that side. So I need to use the law of cosines so that I can find side B. So I'm going to use the law of cosines, and if I back up, if I'm going to find B, it's going to be this one on the bottom with the B squared on the alone there. So it's going to be B squared equals A squared 17.2 squared plus C squared 21.5 squared minus 2 times the two sides we know, 17.2 times 21.5 times cosine of the side across from the side, or the angle across from the side that we want, which is 98.1. And then simplify just like we were doing. So 17.2 squared plus 21.5 squared, enter, 758.09. And then over here, so we have minus 2 times 17.2 times 21.5 times cosine 98.1. That's a negative. It's a negative 104.21. Minus the minus is adding, so we're really going to be adding here. 758.09 plus 104.21 is 862.3. So B squared is that, and then we'll square root. Since this is a decimal already, I don't want to be thinking about radical form. 29.36 is approximately B. Once you have a pair, meaning the angle on the side opposite from it, you can use the law of sines to solve for everything else. So I'm going to use the law of sines now. I'm going to find A first. So if I'm going to find A, I'm going to put side A, which is 17.2, over the sine of A, which we don't know, equal to, and I need to use B because I have angle B. So side, that is B, 29.36 over the sine of angle B, and B is 98.1. So cross multiplying 17.2 sine 98.1 equals 29.36 sine A. Divide here, this is a little bit different because it's the sine of A that is unknown. We're going to divide by 29.36. So really what we're going to be looking at is this, all of this is the sine of A. And hopefully you remember that if we're wanting the angle, we want to do the inverse. So if we type second sine in the calculator, it looks like this with the -1 there. And then we will want to type in, and it will open a parentheses for us. And I like to do this all in parentheses, so my numerator will be in parentheses 17.2 sine 98.1 parentheses divide 29.36 and then end parentheses. I have two sets of parentheses here. I'm going to check if it matters that much in my calculator. So I'm going to hit second sine so in my calculator, second sine And it opened a parenthesis for me. And then what was it on the top? Sine 98.1 and 29.36. And then end parenthesis. And I'm going to double check because I didn't put the extra set of parentheses there. I'm going to check and make sure, see if it matters or not. Second sine, I'm going to try double parentheses in this one. 17.2 sine 98.1 parentheses divided by, I'm kind of weird about my parentheses. This is me just double checking if it matters. 36 parentheses. So let's see, 2 opens, an open, 2 closes, and a close. So that should be fine. Same thing. Okay, good. So you don't have to put the numerator in its own set of parentheses. Just be sure that you end the parenthesis after the 98.1, that it had automatically opened after the word sine, and then you end it again at the end. So second sign is because the unknown is the angle. So I think that dragged it. There we go. Let me go over here. So anytime you want the angle is when you're going to be hitting the inverse function, the second sign. So we had typed it in up here. I typed it in twice, but we got the same answer, so we're good. So angle A is approximately 35.45 degrees. And now we have 2 out of 3 angles. So we will just add them up and divide and subtract from 180. So 98.1 was the other, so I've got 98.1 plus 35.45 is 133.55, and then subtract that from 180. 46.45, and that was angle C. And then make sure you box your answers for me so I can find them. So we've got the 3 pieces that we're missing.